everyone, I'm Wendy. Residual analysis, second time, we are going to study studentized residual. It is a very famous one and it useful tool to represent residual. Okay, let's see what studentized residual. Okay, in obtaining the residual plot, the residuals have units, right? Residual, of course, have a unit, data measurement unit. So we obtain standardized residual by removing the unit. We studied the standardization, the unit. However, if we represent the residual as random variables, in bold EI, if yi minus yi hat, what was EI? EI residual was yi minus yi hat before, just the value, okay? Realize the value of error. But here, I like to represent residual as random variable. So EI equal to capital yi, this is a random variable, yi hat also random variable. So EI random variable, I from 1 to n, this becomes a random variable. Therefore, each residual EI will have a distribution. Every time, anytime, random variable follows some distribution and variance, of course, variance. In other words, the standardized values of each EI, okay, calculated using their standard errors, are referred to as studentized residuals. So studentized residual is EI, of course, minus 0, standard form. So its mean divided by its what? Standard deviation. But we say standard error of EI, right? You know standard error, the terminology, okay? The standard deviation of a statistic, this one is a statistic, called standard error. So standard error of EI. A detailed explanation of this is beyond the scope of this lecture. So it is recommended to utilize the studentized residuals obtained with the help of computer. In other words, it is preferable to generate residual plot using this studentized residual and y hat values. It is, beyond the scope of this lecture. So actually we say orthogonal, but you don't have to worry about that kind of thing. Here, x-axis will be y hat, and residual is y-axis, okay? The residual plot obtained in this way, observations with the studentized residual values outside the range -2 +2 are referred to as outliers, okay? The studentized residual value outside the range -2 +2 are called outliers. Outliers are unique values, not many outliers, some couple of outliers in your data. So it is necessary to interpret them separately. Why these some data are outliers? So you can look at outliers, okay, precisely. And in some cases, it may be advisable to perform regression analysis excluding the outliers. Understanding? Perform regression analysis again, excluding the outliers. So outlier may affect your result. That's why. And you can interpret outliers separately. Okay? So studentized residual is important in what? residual analysis. Second, we need to check. We studied the normality of residual, and we need to check whether the variance is constant. This is the second assumption, right? This involves the checking whether the dispersion of residuals is constant under the assumption that error is this one, assumption of error is this one. So we checked normality, and another thing is equal variance. In other words, constant variance is constant or not. When obtaining a residual plot with the residuals on the y-axis here, usually we use studentized residual here, okay? And this x-axis y-hat. Y-hat values on the x-axis. If the residuals appear to be generally spread within the constant band, like this, constant band, okay? Then we can assume the variances of residuals are equal. So this is okay, okay? Constant variance. This one is what? Studentized residual. However, if any patterns are observed, we cannot assume that the variances are equal. Something like this pattern. Something like this one. What is it? This one. Parabolic. Okay? Then your constant assumption does not hold. Then what? The result of your statistical analysis will be useless. It's not effective. Okay? So then, what can you do? In this case, we have some options. We will later see that uh, some options, it becomes difficult. Okay, this is it today. Thank you. Bye.